Welcome to a TUSD Robotics production. In this video, we will begin to build the robot Rise for VEX IQ using OnShape. Over the next several weeks, we're going to attempt to build this robot called Rise for VEX IQ. This is the robot that was designed to play the game Rise Above, and we're going to do our best to see if we can build this in CAD. This is a set of directions that you can use to build the physical robot when you have a VEX IQ kit. But in CAD, I'm going to import all the parts into documents for you to use virtually. On the second page of the directions, you will see some tips for building. What's most important here is that in these directions, you will count the holes in the beams to figure out which holes you will constrain using fastener or revolute mates. Notice that you can count over 1, 2, 3, and then the green circle is highlighted, so you know that's going to be the hole that you are going to constrain. On page 3 of the directions, you will see there are some tips for building as well. One thing you want to notice is that each of the angle beams has a degree in which it's angled. So in the files that were loaded into OnShape, it would be a 45-degree angle or a 60-degree angle or a 90-degree angle, which looks like an L shape. You will also notice that we measure the axles and the standoffs by the number of holes high they are. So there might be a 3x or a 4x length in axles or standoffs. On the next page of the directions, you will see all the motion parts, and all of these parts have been added into a part folder in your OnShape document. You will see that we have the rubber shaft collar, which we used in the constraints lesson. We also have capped plastic shafts. We have a motor shaft. This is a metal regular pitch shaft, which is 8x long. And then we have 3 gears. These are spur gears, and if you count the number of ridges, they're called teeth. We have a 60-tooth spur gear, a 36-tooth spur gear, and a 12-tooth spur gear. We are not going to be using any rubber bands in this project. You will also find that there are 2 pieces to make the wheels, a rubber tire that's 200 millimeters on the outside, and a small wheel hub. On the next page, you will see all the connector parts that were placed in your connector folder. Now, usually we connect the parts with these blue pins. So you have a 1x1 pin, a 1x2 pin, or a 2x2 pin that shows you the length on each side and how many beams it goes through. So this will go through 1 beam on each side, and this will go through 2 beams on each side. In OnShape, we're not going to use these pins. I did put them into your connector part folder if you want to play with them, but because of their shape in a CAD program, they're very hard to use, and we actually can just constrain the holes of the beams to one another. These are called standoffs, and they hold the beams a certain distance apart. This is a 0.5x or 0.5 length standoff, a 1x, and a 2x standoff. This is an end standoff connector. Over here, you will see corner connectors. We have a 2x1, so it's 2 long by 1 wide corner connector. And it also has 2 connection points at the bottom, so it's a 2x wide. This is the same thing, except for it has a little extra space right there, so it's called an offset. Here we have a 1x2, 2 holes wide. This is a 1x2, but it's offset, and it's 2 times wide. So you can see the names here for all the corner connectors, and they match the names of the parts in your folders in OnShape. Here you will see the electric parts. We're going to use a robot brain and a smart motor. We're actually not going to use these smart cables because that's just way too much to put into this CAD file. Here you will see all the structure parts found in your structure folder. We've got 1x beams, 2x beams, and then a 4x plate. So this is a 1x4 because it's 4 holes long, 1x6 because it's 6 holes long, and now we've got a 2x12 because it's 2 wide and 12 long. I think you get the idea. Once in a while there's a center hole, and only 2 of your OnShape files have the center hole included. The rest are just regular beams. There's also 2 degree angles we will be using, a 45-degree angle and a 90-degree angle. Here's page 1 of our directions, and this is where we're going to begin. Now remember, we're not going to use these pins because we don't need them in OnShape. So what we're going to insert is a 2x16 beam, a 2x8 beam, and then this capped 2x or 2x length pitch shaft. This is a capped pitch shaft, which means that it can spin inside of the hole and it doesn't need to be connected on the other side. That cap holds it in place, and we are going to use a revolute mate for any type of pitch shaft. So let's get started. Okay, so here we are on the iPad app. Make sure you're using an iPad app and not the web-based OnShape website when you're using an iPad. It works much better using the app. So here we are in the iPad app, and it looks like this with our menu. And I'm going to go to the Shared With Me, and you will see a new lesson has been shared with you called Rise Robot. So I'm going to go ahead and tap on the Rise Robot document. And before we can make any changes, we're going to need to make a copy of this workspace because this is view only. Okay, so I'm going to go up to the three dots and click copy. I'm just going to keep it the name it is and hit enter or return. So this document is pretty big, and if it takes a long time to copy the workspace, just hit cancel and then try it again, and hopefully it will work sooner than later. It is a pretty big file because each of these parts, and there's a lot of parts, require a lot of memory. So once you've made a copy, it's now editable, and you know this because when you hit your little menu folder icon with the little caret arrow in the bottom left corner, you have a plus sign. Now, if you're not seeing these folders and you're inside of the structure folder where you have all the structure, you can just simply go back to the main parent folder by hitting that arrow next to structure. And this is what we call the parent folder. Now, I already have one assembly in here, but you're going to create a new assembly to try and make what I made. So we're going to use the plus sign, and we're going to create an assembly. And this will probably be called assembly 1 if you don't have that assembly name yet. And then once we have the assembly, we can start inserting parts. Now we're going to look at our directions in step 1. And remember, I said we're not going to use these blue pins, but we're going to use those green highlighted circles to count where we will constrain those circles where the pins would have gone. So I'm going to count 1, 2, 3, and you can see down on the long beam, we are going to connect the third hole on the long beam to the second hole on the short beam. So the first thing we're going to do is going to insert those beams. So I'm going to use that insert icon in the top left corner, and I'm going to look for the part which is called a 2x16 beam. I'm going to scroll down a little bit. Once I find my 2x16, it's right here. I'm going to tap on that and check mark to accept. Okay, now before we add any more parts, I want to teach you how to fix this part, which is very important in making CAD models so that you can go back to the isometric view. When I tap on the view cube and I tap isometric, we want this beam to look like it does in the direction. So it'll always be brought back to this isometric view. So in order to do that, I need to select the beam, and then I'm going to use the arrows to rotate, this arrow right here, to rotate it so that it looks like it's isometric just like the view cube. That looks about right. So now I'm going to go over to my 2x16 beam in the parts list on the left column. I'm going to use the three dots next to the 2x16 beam, and I'm going to tap Fix. And when I fix this, no matter what happens, when I go back to isometric view, everything that's attached to this beam will come back to this view. So if I go ahead, deselect by double tapping the screen, and then if I turn my view cube, watch how it turns now like this. And if I get lost and turned, I can just go back to isometric and it goes right back to its home position. So we're going to fix this 2x16 beam so that it's our isometric view. All right, now let's insert our next part. I'm going to insert, going to the insert menu. This time we're using a 2x8 beam. I scroll down to find my 2x8 beam right here, and then I'm going to insert and check mark to accept. Now it looks like they just came in overlapping each other, so I'm going to select one of them and move it off to the side, just like this. Okay, perfect. Double tap to deselect. When you look at step 1, you will notice that you need to insert the capped plastic pitch shaft, the 2X, before you put these two beams together. So I'm going to insert one more part. I'm going to go to the insert menu, and this time I'm looking for the 2X capped pitch shaft. So I'm going to scroll down quite a bit. And here's my pitch shafts. So I want the 2X capped pitch shaft right here. And I'm going to go ahead and tap it in my check mark to accept. All right, again, it's a little bit too close to the other beam, so I'm going to select it and move it over just to get it kind of out of the way. Okay, double tap your screen to deselect the part. Okay, so now I want to zoom in and I want the top of this pitch shaft to be constrained to this hole right here. I'm going to use my selector to show you. Double tap to deselect. I'm going to use this hole right here I'm going to put the pitch shaft into that one. So I'm going to use the revolute mate because anytime we use a pitch shaft or any type of axle that spins, we're going to use the revolute mate. So I'm going to go to my mate window by tapping the icon. I'm going to go to revolute. And now I'm going to use my selector by putting my finger down on the white space and dragging it over and looking for those points. Now look at all the points. I'm going to hover over. I want the top center of my capped pitch shaft as my first point. And then I'm going to use my selector tool and come over. I'm not going to use this one. I want this second one right here. Now notice that there are multiple points in that hole. I want the top one right. Whoops, that's too high. I'm going to actually, oh, it worked. You can zoom in a little bit if you want to as well. But I'm going to go ahead and accept. And notice that we've got that cap is flush or even with the edge of that beam. Now, if you get lost, I can just go back to my isometric view and it brings it right back. Okay, so that looks pretty good. Now, I do want to show you, if you have it going the wrong way, you can make some adjustments in the property window. So if I go to that revolute mate and I tap the three dots and I go to edit, notice that there's this little arrow at the bottom, and that will change the axis, the direction of the axis. So if it's going the wrong way and it doesn't look like mine, you can tap this to make it go the right way. And there's also a revolution or rotation where it turns it, but we don't need this because it just spins in the hole. So if for some reason you're just going the wrong way, this adjustment right here, this little arrow, might fix it. All right, I'm going to put it back the correct way, hit the check mark to accept, and we're ready to move on. So now we're going to take the second hole that is right next to, I'm going to use my selector tool to show you, the second hole here and the second hole here has pins in them that attach to the third hole on this beam right here. So we're going to try and attach it to this third hole and this third hole. But because we're doing CAD, we only actually need to do one of them. So we're going to save a little time. Okay, so now we're going to use a fastener mate because you are going to glue these pieces together. We're not going to use the pins. We can just straight fasten the holes together. So I'm going to go to the mate window by tapping the mate icon or the constraints icon in the top left corner. This time we're going to use a fastened mate. And the fastened mate property window opens. I'm going to use my selection tool. I'm going to come over here and I'm going to select the top of this hole right there. Not that middle or the bottom, but the top of it. And then I'm going to come in. I'm going to zoom in this time a little bit. I'm going to come in here and I actually I need to turn this around. So the 3D view cube still works in the middle of your constraints. You can't use your fingers to move the parts, but you can use this view cube and select a different view. So I actually want to go to the back of this beam right there. And I'm going to use my selection tool and I'm going to choose this third hole right here. Actually, I want to zoom in a little bit, make sure I'm getting it right. Let's see the center point of that hole. Let's see if we got it. No, right there. Let's see if that works. All right, looks like I'm going to accept it just to see what we're going to play with. And if I turn it around, it's definitely going the wrong way, for one. And it's too on top of the other beam. So let's try and make some edits. And if it doesn't work, we're just going to delete and do it again. So I'm going to go to my fastener mate. I'm going to edit. I'm going to start by trying to just flip the axis and see if that looks pretty good, but my pitch shaft is still going the wrong way. Let me see if I hit accept if it changes. Oh, it does. Okay, so now it looks like it's the right way. It just needs to be offset because these beams are overlapping a little bit. Okay, so let me open that back up again. I'm going to edit because I need to offset. Let me try to offset it. It looks like it's going on the Z axis. So I'm going to offset the Z. Let's just try 0.5 inches to see what that does. Oh, and first of all, it went the wrong way. So we definitely need a negative 0.5. Okay, and that's too far away from the other beam. So let's reduce that to a negative 0.1. Let's see what that looks like. And it still needs a little bit more of the gap closed. So let's try a negative 0.05 and see what that looks like. And that looks perfect. So I'm going to use the check mark to accept. And here we go. We look like we have completed step 1. Our two beams are together, and we have this pitch shaft going through one of the beams and sticking out the other side. All right, let me go back to my isometric view to center and go home. All right, perfect. Now let's go on to step 2. On step 2, you can see that there's many pins that we're going to put in, and we're actually not going to do that. You can see that it's the last 4 holes that are connected here on both beams. I'll point them out. We're going to do a pin there, one there, one there, and one there. But because we're not using pins, we're actually going to skip step 2 for the moment and go straight into step 3. Okay, in step 3, you will see again there's lots of pins. We don't need to worry about that, but we do need to count the holes. And this time we're going to use a motor shaft. And the motor shaft has a little bit of an extra end that sticks out that goes into the motor. So let me go to my insert menu, and I'm going to look for the motor shaft that was imported. Here's my shaft. So I'm going to go to the pitch plastic motor shaft, that's 4X, and then I'm going to accept with the check mark. And this time you'll notice that, let me go ahead and move this over a little bit, select it so I can move it. This time you will notice that this pitch shaft has a ridge at the top. And we want this ridge right here, that little ridge, to sit flush against the beam so that this end here sticks out that will go into the motor. Okay, so we're going to use a revolute mate because this is another pitch shaft. So I'm going to go to my mate window. I'm going to go to revolute, and I'm going to use my selection tool by using my finger down on the screen and moving it over. And instead of, we don't want the top this time, we want to go down to that little, I'm actually going to zoom in a little bit. Look like I had it there. I'm going to go back. I want this right, remember you just got to hover over to find it. I want to get that right there. That works perfect where that center of that little disc is. All right, there's my first one. Let me go down to zoom in a little bit down here. So now I'm looking for the 5th hole. Let me move this over a little bit. Use my selection tool. I'm going to go 1, 2, 3, 4, 5th hole over. And I'm looking for the top of that hole, just like that right there. And if it doesn't select it when you take your finger off, hit that little white dot in the middle. And it looks like it's going the wrong way, which is no big deal. I'm just going to use my arrow and flip the axis. And that looks perfect. Check mark to accept. So now we've got 2 of our pitch shafts going through just like the directions. Now let's move on to step 4. And in step 4, you're going to see that we use another capped pitch shaft, but this time it's a 3X. And the reason is because this first one that we put in is a 2X. It only went through one beam. Now we're going to go through this hole right here, and it's got to go through 2 beams, and the amount that sticks out needs to be the same. So I'm going to go to my insert menu, and this time we're going to do a 3X capped pitch shaft. Scroll down a little bit, find your pitch shafts. All right, so I'm going to do a capped pitch shaft 3X this time. I'm going to go ahead and move it out of the way a little bit. Let me just tap it to select it and move it a little bit out of the way. Okay, oh, I need to accept with the check mark over in my insert menu. And now we're going to do the same thing we did on the first one, where we're going to use the revolute mate. So I'm going to open my mate window, and because it's a pitch shaft, we're going to use revolute. I'm going to come over here with my selection tool, and I want the top center of that capped pitch shaft. So there's our first entity selected. Now I'm going to come over here and pick my second hole, which is going to be this second one. Now notice I've got 3 different options here. I want the one on the top of the hole right there. Again, it's going the wrong way. No big deal. I just use my arrow to flip the axis and accept. All right, there we go. We've got 3 pitch shafts and 2 beams connected. And we're going to just do one more thing for this lesson to finish off step 4, which is to add a corner connector. Okay, so now I'm going to add the corner connector, which means I'm going to go to my insert menu, and I've got to find the corner connector that looks like the one in the directions. It has 5 holes in it. So it is actually, when I look down, it looks like it is a corner connector 2XY because it has 2 pegs, 2 by 2. So I'm going to insert that corner connector and check mark to accept. Okay, let me move it a little bit out of the way to get it over here. Double tap to deselect my part. Okay, so now I am going to use these pins right here. These pins are going to be inserted into one of these 2 holes. So the trick here is the top of these pins are very hard to constrain. So we're going to go down to the base of this pin right here, and we want the base of the pin to then be flush with or even with, oops, double tap to deselect my part, to be flush with this hole right here at the top. So we're going to go ahead and use a fastener mate. I'm going to go to my mate window. I'm going to use fastener mate, and I'm going to come over here to select the base of the pin. Not any of those in the peg. You could use the bottom one in the peg. There's more than one that you can use. That one would work fine too. I'm going to use that one. Okay, it doesn't look like it's selected, so I'm going to tap that white dot to select it. And now I'm going to use my selection tool again and come on over and choose I'm going to choose this top hole right there. Make sure you're not using the bottom. Let me go hover in. Looks like right. Actually, I'm going to zoom in a little bit to make this easier. Use my selection tool. Will it work? Come in. For some reason, it doesn't want to do it. So let me go ahead and zoom out a little bit. Okay, for some reason it's having problems, so I'm just going to close out that fastener mate window. Not a big deal. Or if it doesn't work, just delete your mates and start over. It's really just how you do this. Let me go back to my fastener mate and tap on that. Let's try this again. I'm going to try the hole first this time. So I'm going to come over here. I want the top of this hole right there. And then I'm going to use my selection tool, and I'm going to use the base of this pin right there. All right, let's see what that looks. Oops, it didn't select it, so I'm going to tap that white dot in the middle. And it looks pretty good. However, I need to rotate. I'm going to use the rotation adjustment, and that looks like it worked. So I'm going to hit the check mark. You might have needed to use the axis flip, but I didn't here. So this is actually the end of our lesson, and we've completed steps 1 through 4 in the directions. Now, if this is easy for you, you have the directions, you have all the parts, you can keep going. But this is quite a lot to have accomplished in one lesson. So if you've gotten this far, big accomplishment, you should be very proud. On our next lesson, we will begin with step 5. All right, thanks for watching.